friends, welcome back to my YouTube channel Spectrum Science Hub. I hope all of you enjoyed my previous sessions in astrophysics. Today I am discussing the next session in astrophysics, Astrophysics-5. I am discussing Karnataka University Dharwad BSc second semester as well as the sixth semester also. It is a common syllabus, astrophysics. Now let's come into the relation between absolute, apparent magnitude and distance. Before starting this session, I would like to request you, please subscribe my YouTube channel Spectrum Science Hub and press the like button. And also please share these videos to your friends also. Now let's welcome back to the relation between the absolute, apparent magnitude and the distance. Let us consider the two stars. 1 and 2. Here the two stars 1 and 2. Here the stars are there. There are two stars are there, 1 and 2. Now we know that here the absolute magnitude is represented by capital M and apparent magnitude is represented by the small m. Whereas the star 1 is having the apparent magnitude M1 and star M2 is having the apparent magnitude M2. And also the luminosities of this star 1 is L1 and the star L2 is L2. And also the brightness of the star 1, the brightness of the star 1 is B1 and brightness of the star 2 is B2. And the magnitude of the star 1 is M1 and the absolute magnitude of the star 2 is M2. Now we are considering the two stars here, 1 and 2. Their apparent magnitude is M1 and M2 and their luminosities L1 and L2 and their brightnesses are B1 and B2 and the absolute magnitudes of the two stars M1 and M2 respectively. Now we know that in the last session we have discussed the expression for the absolute magnitude, that is the difference of the absolute magnitudes. This is not the absolute one, this is the apparent magnitudes. Apparent magnitudes, that is M2 minus M1 is equal to 2.512 log B1 divided by B2. We know that just M1 and M2 and also B1 and M2 are the brightness of the two stars respectively. We have all the relation between the brightness and the luminosity of the star. That is for star 1. For star 1, B1 is equal to L1 divided by 4 pi D1. Where D1 is the distance of the star 1 from the surface of the earth and D2 is the distance of the star 2 from the surface of the earth, and L1 and L2 are the luminosities and B1 and B2 are the brightness of the two stars respectively. Call it as equation number 2 and 3. Now in this put D2 is equal to 10 parsec. This is the definition. Put D2 is equal to 10 parsec in this equation 3 and put small m2 is equal to capital M2. That is what the apparent magnitude is replaced by the absolute magnitude in the equation number 1. Therefore, equation becomes M2 minus 1. This equation 1, M2 minus M1 is equals to 2.512, 2.512 as it is and the log as it is and B1, B2. Equation number 2 and 3, log B1 is equal to L1 divided by 4 pi D1 whole divided by, now B2 is equal to L2 divided by 4 pi D2 square. In place of the D2 square, put the D2 is equal to 10 parsec whole square. If you calculate all these values, we are getting M2 minus M1 is equal to 2.512 into 10 parsec whole square divided by D1 square. Now here, we know that the value of the parsec, 1 parsec and put that 10 parsec is equal to the 32.62 light year in terms of the light year, and L1 is equal to L2 is equal to L. That is the luminosities of the star we are going to find out. Now here M1 is equal to M and M2 is equal to capital M and also D1 is equal to D2 here. Therefore this equation becomes M2 minus, call it as equation number 4 also, or we can say that the equation number 4. Therefore the equation 4 becomes this, in place of M2 here capital M and in place of the M1 only M1 is equals only M, is equal to 2.512 into 10 parsec. In terms of the light year, 32.62 divided by d1 square. In place of the d1, put d. Therefore, if you work out this one, we are getting capital M minus M is equal to 5 log d. 5 log d minus 5. Call it as equation number 5. Call it as equation number 5. This equation 5, the equation 5 is the relation between the absolute magnitude, apparent magnitude, and the distance of a star from the surface of the earth. Here in this equation number 5, the term m2 minus capital M minus small m, that is the absolute magnitude minus the apparent magnitude, is called as the distance moduli. This is the equation number 5, where we are getting the relation between the absolute and the apparent magnitude of a star with the distance of a star. Okay, friends, let's coming to derive the expression for the radius of a star. Now we are at a new position to derive the radius of a star. The expression for the radius of a star can be found out by comparing its luminosity with the luminosity of the sun. Okay, now let L star, R star and T star are the luminosities and radius and the surface temperature of a star. Here suffix star means these are refers for the stars, star values, luminosity, radius and surface temperature of a star. Now let's coming to the sun. Here the diagram, the circle and at the center of the circle a dot, it refers to the sun. Okay, in astrophysics it is an aberration. Now L, R with respect to sun, L, R and T are the luminosity, radius and surface temperature of the sun. And also we have the expression for the luminosity. We have the expression for the luminosity of any star is given by L suffix star is equal to, this equation is already derived. If you do not know, please refer my previous videos. The luminosity of any star is equal to 4 pi radius of a star r square sigma t to the power of 4. Now for the luminosity of the sun, therefore the luminosity of the sun is equal to 4 pi r square sigma t to the power of 4. Call these as the equation number 1 and 2. Now divide equation 1 by 2. We get the equation 1. Here L star is there in LHS and the L with respect to sun is there. Therefore L star divided by luminosity of the sun is equal to 4 pi r square sigma t to the power of 4 and divided by for the sun 4 pi r square sigma t to the power of 4. Here 4 pi get cancels and sigma get cancels and the remaining factors are there. The r star divided by r sun whole square divided into here t power 4 and with respect to sun t to the power of 4 is there. Therefore t star divided by t sun to the power of 4 is there and we need the radius. Therefore this factor is taken in the LHS. Therefore the r star divided by the radius of the sun whole square is equal to the L star, keep it as it is, L star divided by L to the luminosity of the sun into here the surface temperature of the sun divided by the surface temperature of the star to the power 4. Okay, here square is there. Remove the square on both sides. Put the square root on both sides. We are getting r star divided by r naught is equals to here L star divided by L sun is there. Here half it comes, here half is there. Here. Therefore here to the power of 4 is there. Here if you put the root, here half into 4 it becomes 2. Therefore finally you are getting the radius of the any star. Radius of the any star is equals to, it goes here or it's said the radius of the sun into bracket these factors as it is. Okay, this call it as equation number 3. The equation number 3 gives the radius of the any star by comparing the luminosity of a star with respect to the luminosity of the sun. Okay, thank you very much.